Hello, welcome to another video. And this video is special because this is about the projectile motion in a presence of air resistance. What will be its trajectory and how is this acceleration direction changes? We will see in this question. So, first of all, it is important to know that what will be its trajectory in absence of air resistance. So, if I'm throwing this ball at some angle, at an angle bigger than 45 degrees, let's say at this angle. So I have thrown it like this, and I'm assuming it's a free fall motion. There's a no air resistance. So you know that its trajectory will be like this, parabolic. Okay. But in absence of air resistance, this is a trajectory. In a presence of air resistance, it doesn't follow this path. Rather, it neither covers that much horizontal distance, which we call range. I'm talking about this, nor it go to that height which we say like the maximum vertical position. So both factors are equally affected when air resistance plays its role. Okay, so what will be its trajectory in a presence of air resistance? So that would be look something like this. So you see clearly that it's both distances are affected. So in this question they say when it is moving and when it is at an angle 45 degrees during the motion at some time t, when it is at an angle 45, so I assume that it is, let's say it is, suppose it is at that point. Okay, so this is its instantaneous velocity, and which is at an angle 45 degrees. Right at that point, what will be its acceleration? By the way, this shows absence of air resistance. So in absence of air resistance, no matter whatever the position of the ball is, at highest point or just before hitting the ground, at all of those points acceleration will be vertically downward, that is equals to negative g. Okay, but this acceleration is affected. And why is that? Because just imagine the ball is right now at this angle 45 degrees, and like this is a direction of its motion. I can say this is a direction of motion. So air resistance always opposes the motion. It does not uh, apply in a specific direction, it opposes the motion. So that's why the imagine that these are the air fluid streamlines, and this air is trying to drag it in an opposite direction. So what will be the direction of the drag force due to the air? That will be the direction of the drag force FD. Okay, now if I draw the free body diagram, so you will see there will be the two forces exerted at this time on this ball. So this is the ball, and the drag force is exerted exactly at an angle 45 below the horizontal, right? And the force of gravity is downward, that is the weight of the ball. Now this drag force have a two components. You see the one component is towards left, which tries to pull the ball backward, does not allow to go the ball in that much horizontal distance. That's why it covers less distance. Okay, as well as the vertical component of this drag force pulls the ball down. That's why the ball doesn't go to that vertical position in which it goes in absence of air resistance. So I hope you understand that the resultant acceleration that we will get and the resultant force that we will get, it is a sum of these two forces. Okay, so what is a resultant of these two forces? The, that will be diagonally between them, right? So this is what we can say, the resultant force, the F net. But how did we get that? We have got it by adding this vector into this vector. Okay, so this is the resultant force, and this resultant force will produce the resultant acceleration, which will be also in the same direction. Okay, so acceleration direction is obviously not c or d because it's not downward. It is either A or B, but remember that acceleration, what is the net force? Can I say the magnitude of the net force? I'm saying magnitude is the sum of the drag force and the force of gravity. So that's why the acceleration is equals to the magnitude of acceleration is the sum of these two forces divided by mass. That's why it must be more than g. So that's why the right answer should be option B. I hope you understand.